Hello everyone, welcome back to Functional Studies 101. Today we are looking at exercise 3 on the Adamawa Regional Competition of Mathematics. If you are new to this channel, this is Temgun48 presenting these scripts. Don't forget to subscribe, like and share the video after watching. And also don't forget to turn on this notification bell so that whenever new uploads are made available, you will not be left out. To get to me, you can email me at temgun48@gmail.com. You can also send me a WhatsApp message using the number on your screen. So without wasting much of your time, let's get into business. Okay guys, let's get into the question proper. So the question reads, for what value of m and n will the number 42m, that's 42m 37n, be divisible by 33? We know that for a number to be divisible by any other number, it must also be divisible by the factors of that number. Okay, so if this number is divisible by 33, it should be divisible by all the factors of 33. So what are the factors of 33? We recall that 33 can be rewritten as 11 times 3. Okay, yes, so 33 has two factors excluding one and itself. It has two other factors, 11 and 3. So if this number is divisible by 33, it must both be divisible by 3. Okay, it must be divisible by 3 and 11. So in that case, we start with the first one, divisibility by 3. A number is said to be divisible by 3 if the sum of its individual digits is also divisible by 3. So it means it must be a multiple of 3. Okay, so in that case, when we see the sum of the individual digits, we have just to sum these numbers as you are seeing. 4 plus 2 plus m plus 3 plus 7 plus n individually, sum them up. The answer should be what? A value that is a multiple of 3, and that should give me 16 plus m plus n when you simplify it. So since this number is divisible by 3, this answer that we get here, according to divisibility test by 3, the sum of its digits must also be divisible by 3. So it means it must be a multiple of 3. Okay, so in that case, we are saying that the remainder is 0 when it's divisible by 3. When this is our sum of the digits, when you sum them up, it should be giving you a number that will give you a remainder when it's divided by 3. So it means it's a multiple of 3. So you can write it in congruent notation as 16 plus m plus n should be congruent to 0 mod 3, that the remainder is 0. That's equation 1. We now look at divisibility by 11. A number is said to be divisible by 11, listen up, when the alternating sum of its digits is also divisible by 11. So when you talk of alternating sum, okay, alternating sum of its digits. So the first number is positive, the next one now will be negative. Okay, consider the first number to be positive, the next number will be negative, just like that. And m will now be, that's positive, negative, positive. Alternating sum of its digits should be divisible by 3. So we are saying that 4 minus 2 plus m minus 7 plus 7 minus n. So we are alternating the sign of the summation. Okay, we alternate it. This alteration should give you a value which is also divisible by 11. So where you simplify that, you have 6 plus m minus n. Okay, since this number is divisible by 11, so it means that it will leave no remainder, right? The remainder will be 0. So we can write it as 6 plus m minus n should be congruent to 0 mod 11, or better still, a factor of 11. That's my equation 2. So now from here, since we have to solve these two equations together, we have to solve them together simultaneously. So this is how you have to know. We have said that this number is a factor of 11. is equivalent to saying that it is congruent to 0 mod 11. Another way of saying it's a factor of 11 means that what this number, rather 11 is a factor of this number, okay? So it leaves no remainder when divided by 11. So this number must be a multiple of 11, multiples of 11. So you can have multiples of 11. You have both positive and negative numbers, both positive and negative multiples. So 0 is a multiple of every number. We know that 0 is a multiple of every number. So what are the multiples of 11? We have 11, both the positive and the negative. The next one, remember the multiples of a number, they are those numbers that we obtain when we multiply by any other number, okay? So when I multiply 11 again by 2, I have 22. So including, you can multiply by negative 2, you have negative 22. Just like that, you'll be having plus or minus, you multiply by 3, minus 33, plus or minus 33, and so on. You just go increasing like that. But that's why I put these 3 dots, or you can see there. So those are the possible values that this expression can take. Just like that, multiples of 3. But recall this condition. We know that my m and n, okay, they are unit numbers. They cannot be negative, it can be 0. It is not a double number, so it means that it can take a value. Both m and n can take values from 0 to 9 inclusive. Anything out of this zone will be invalid or impossible to say. So let's look up, okay? That's what I had in the previous slide, and I'll just copy down my expression here so that it will help us make the argument. Remember, my m and n, they are values between 0 and 9, which means that the difference between the two values, right, it can either be positive or negative. The highest positive difference can be what? 9 minus 0. That's the highest positive difference that we can have. Then the highest negative difference can be what? The highest negative difference can be what? 0 minus 9. Okay, 0 minus 9, which is negative 9. So we'll start with analyzing the negatives. First of all, 0 is neutral, so it has no sign whether it's positive or negative, it's just there. So the first thing that we know that this expression can take, okay, look up. Whatever we have on this side of the equation will determine the sign, because this negative 6 has to come here, okay? And we have seen that the highest negative value of this difference can be what? 0 minus 9, which is negative 9. So when this term crosses, it will become negative 6 plus whatever we are going to add here from this group of numbers. So I have negative 6 already this way, and the highest negative value you can take is what? Is negative 9. So if I add 0 to it, it's a possibility. So the first possibility is that 6 plus m minus n can be 0. Is a possibility. So it means that we are saying that m minus n can be equal to negative 6. That's the first possibility. Now let's do the second argument. Can it be negative 11? Let's analyze all the negatives first. When this term crosses here, it becomes negative 6. When you add negative 11 to it, it becomes negative 17, which is already greater than negative line. Remember, we said the highest negative of this difference can only be negative 9 for this expression to remain true, right? Because that's 0 minus 9. The highest difference should be that. So there you have negative 17. That's negative 6 plus negative 11 is already greater than negative 9. So that is impossible. So it means that the only possible value of n that we can have here is 0. That's for the negatives. Analyzing for the negatives. All the negative will not work. Let's try for the positive. When we take a value like 11, the least positive value there is 11. Positive 11, when we put 11 here, it will become negative 6 plus 11, which you know is 5. It's a possibility, okay? Because remember the difference, the highest positive difference is what? 9 minus 0, which is what? 9 now. And 5 is less than 9, so we consider it. So in that case, the highest positive difference is 9. So in that case, we can have another possibility. 6 plus m minus n can also be equal to 11, positive 11. So we are saying that m minus n can also be equal to 5. That's another possibility. Now, can the number be 22? Let's see. Negative 6 plus 22 is equal to what? Negative 6 plus 22. So you can subtract that will give me positive 16. It's already greater than positive 9. So it's out of the region, out of this region. So in that case, that is not a possibility. So it means that any other positive or negative value that we'll consider apart from these two, okay, anything greater than this one now, 22, 33, and so on, going upward, will not satisfy this our condition, this constraint. So in that case, these are the two possible cases that we have. Okay, we will now use this to solve our equation. So the first case, we have that 16 plus m plus n is congruent to 0 mod 3. This was our equation 1 that we derived above. So we'll consider the first case when m minus n is equal to negative 6. M minus n being equal to negative 6. Please don't mind the noise outside. They are doing some construction outside. That's why there is noise. Just focus on what I'm explaining here. So m minus n is equal to negative 6. That's the first case. It means that my m will be equal to what? N minus 6. We now come and replace it in equation 1. That will give me 16 plus this m is equal to n minus 6 plus this n is congruent to 0 mod 3. So we simplify that. You have 10 plus 2n is congruent to 0 mod 3. And 10 in mod 3, what's the remainder when 10 is divided by 3? Is equals to 1 now. The remainder is 1. We'll go 3 times remainder 1. Write down the remainder. When you are doing modular arithmetic, that's how you do it. You feel free to simplify it. So that will be 1 plus 2n is congruent to 0 mod 3. Good. Finally, from here, this 1 can cross, so that I'll have 2n to be congruent to negative 1 mod 3. And negative 1 in mod 3, when you have a negative number in a particular modular, you can add positive multiples of that n so that the number becomes positive. It's a possibility. So when you add negative 1 plus 3, you have 2. So 2n is congruent to 2 mod 3. And clearly you can see that this can cancel out. It's a possibility. Okay, so n is congruent to 1 mod 3. Or in other words, we say, what is the multiplicative inverse of 2 in mod 3? The multiplicative inverse of 2 in mod 3, when you do it, is 2, because 2 times 2 is 4, and 4 is congruent to 1 in mod 3. So in that case, you can multiply both sides by 4. That will turn into 4n. I mean by 2, that will be 4n, and that 4 will be congruent to 1 in mod 3. So you just have n, which is congruent to 4 in mod 3 is just 1. So, or you just divide. These two are common factor. You can just divide. You have any congruent to that. So when you write it like this, it means that you can transform it as a linear equation in the form n is equal to what? 1 plus 3t, where t is an integer, using division algorithm. So now let's test. Remember, n can take values from 0 to 9 maximum. Okay, so t is an integer. Can t be 0? Yes. When t is 0, n will be 1. But remember, our m is equal to n minus 6, and m also lies in this zone. So m must be positive and less than 9. So it means that for this number to be positive, n must be greater than 6. So when we put t equals to 1 here, we'll have n equals to 1, which is not a possibility for this condition to hold. So we take the next one, t equals to 2, we'll have 6 plus 1. 6 plus 1 is 7, it's a possibility now. So n is possibly 7, n can be 7. And if n is 7, what will be the value of n? We come and replace here, n will be 1 now. N will be 1, that was 7 minus 1. Can t be 3? Let's see, 3 times 3 is 1, is 9, right? 9 plus 1 is 10. And 10 minus 6, what do you get? First of all, 10, n equals to 10 is already out of this zone. So it's not a valid condition, it's not a valid value of n, so we ignore it. We'll go to the next one. So the next case, we recall again this our expression because it's the same argument we use our case 2 now, copying down equation 1 again. Our case 2 says n minus n can also be 5, so it means that n should be equal to n plus 5. From here we replace in equation 1, that will give me 16 plus n plus 5 plus n equals to what? Is congruent to 0 mod 3. Simplifying, you have 21 plus 2n is congruent to 0 mod 3, and 21 in mod 3. What's the remainder when 3 is divided by 21 is divided by 3 is 0 now. So this one will just be 0, you'll be left with 2n is congruent to 0 mod 3. So 2n is congruent to 0 mod 3. So clearly we have that n should be equal to what? 0. So we can see that our n is congruent to, we can divide both sides by 2, you have n is congruent to 0 mod 3. So it means that we are saying that what? Our n should be a multiple of 3, that's the meaning. So if n is congruent to 0 mod 3, means that my n should be a multiple of 3. So multiples of 3, we know it starts from 0, it can be all positive and negative, okay? But if we take negative multiples of 3, it means that n will not be valid. N must be positive, so we have t must be what? A positive integer that we'll consider here. So t must start from 0. Can n be 0? Yes. In that case, remember, if n is 0, m will be 5. So it's a valid condition. Can n be 2? Let's see. Can n be 2? Remember, we are considering only multiples of 3. After 3, t can be 1 times 3. Okay, values of t, you can have t equals 0, t equals 1, and so on. Okay, when t is 1, we'll have 3, n equals 3. Okay, so in that case, if n is 3, we'll be having 3 plus 5, which is what? 8. So m is equals to 8. It's a possibility. It does not exceed this zone. So this is another possibility. Then now when t is equals to 3 now, we'll be having 3 times 3 is 9. N is equals to 9. But when you put 9 here, you'll be having 9 plus 5, which is already a value 14, which is greater than 0. I mean, it's greater than 9. So it's out of this zone. So it means that what those other values from t equals to 3 and above will give an answer that is invalid to the problem. So in that case, the only solution that we have, the 3 pairs of integers m and n. The first one we had when n was 7, m was 1, so we write it like that in that order. Then now this one, m is 5, n is 0, and n is 8, m is 8, and n is 3. So these are the 3 possible solutions, 3 possible integers that can fit into this position and make this equation to be correct. You can test it for yourself. Can we do the testing? You can test for yourself. Okay, you can test for yourself. Normally when you test, you will have the answers. So this is the end of the tutorial. Hope you enjoy it, and please share the video. I'm begging, share it to your students, your colleagues, and some other people. Let the video go viral so that it will encourage me to continue creating these PowerPoint presentations for you that will help you to aid in your teaching career and so on, help your students pass exams and more. Thank you for watching. See you guys in the next tutorial. Bye bye. This is Temgun 48 signing off.